Now we will talk about water supply fixture unit calculation. Okay, why water supply fixture unit calculation is important? Because you should calculate water flow rate. Okay, as I told you when we gone through the codes and standards, I told you that this is based on probability method. Okay, say for example you have a 10 toilet. Okay, so you cannot say that at the same time 10 toilet will be used, right? Say for example if I go to one of the diagram, okay, where you can see there is a toilet set, right? So you can see that there is a different WC, then you have a urinal, okay, then you have a ablution area, then you have a wash basins. Okay, so when you do the pipe sizing, you will be doing the pipe sizing based on the water flow rate. Okay, so this water flow rate you cannot apply directly. Say for example I have a wash basin, assume that I have 1 liter per second required, assume, okay, or I will say in GPM, 1 GPM is required, assume, right? So if I calculate all the wash basin, if I calculate all the WC, if I calculate all the urinal, if I calculate all the ablution area, okay, say for example I have a 50 GPM, assume, okay, so I cannot size my pipe for 50 GPM. I can size my pipe for 50 GPM, but it will be the project cost will go high, and it is not necessary basically. Okay, why it is not necessary? Say for example if I go to the toilet, maybe you can go to any of the even peak, even you can go to the airport, right, where you have a peak conditions, or you can go to the mall where you have a peak condition. See, suppose if you see the public will be using the toilet, okay, say for example all the WCs, all the toilet is occupied, all the urinal is occupied, all the people are using urinal, all the people are using the ablution for washing the hands or foods, okay, and you can say that all the people are using wash basin, okay, but what will happen, you cannot say that at the same time they will be using the fixtures. Say for example when somebody is using this toilet, okay, you will not be flushing all the time, right? You will be using flushing at particular time. Okay, say for example urinal you will be using at particular time. Okay, ablution area maybe out of 4 maybe 1-2 people are using, or maybe some people are using less water, more water. So this is basically based on probability method, so they don't use water in all the time. Okay, so that is why we are going to calculate the water flow rate calculation based on probability method. So how to calculate water flow rate based on probability method? That is why the IPC standard says that water supply fixture unit calculation you have to do prior to water flow rate calculation. Clear, right? So you can say that this is the water supply fixture unit calculation. Okay, so in the water supply fixture unit calculation, if you remember, I have gone through the, if you say if you remember that when we gone through the codes and standards, right, you can see that there are different type of fixture category, right? You can able to recollect. If you go to the codes and standards, IPC standard, we have seen that fixture occupancy, and based on the IPC table, water supply fixture unit calculation, you can see there are different fixtures, right? Right, you have a urinal, you have a lavatory, you have a bidet, you have a bathroom group, then you have a wash basin, washing machine, or you have a water closet, hose bibs. Okay, so these all from the standard. Okay, so if you go through the standard, you have a value for cold water, you have a value for hot water, then you have a value for total fixtures, right? You can able to collect Nisar, Guru, Rajesh.
Yes. The total. What is the total fixture unit? It's,
okay, see, I will tell you that there are some pipe is used only for cold water application. You are using for only cold water. What is cold water? Say for example, if you talk about WC, I am using only cold water, right?
Yeah.
If you talk about, say for example, urinal, I will be using only cold water, not hot water. So whenever you design the pipe size, you can design the pipe size based on the cold water fixture calculation, right? Okay, but if you talk about this particular pipe, so this particular pipe I will be supplying to the hot water and as well for the cold water, right?
Yeah.
So this particular pipe I will be sizing for as per total. Okay, because when you go to this particular calculation sheet, say for example I have a 2.7 cold, okay, hot water will be 1.5, but what should be the total? Should be the total like 4.2, but it is not 4.2, it is only 3.6, because you will not be using hot water at full capacity, right? You will be mixing with hot water, so your water usage will be lesser when you use hot water, when you use the combination, right?
Yeah.
So that is why the total will be total will be lesser compared to the cold water or hot water. Okay, so this is what standard says, right? So you can go through this particular water supply fixture unit calculation. You can go through all the cold water pipe size. This value based on the IPC standard. This value is based
Yeah,
on the
okay.
IPC standard. This value is based on the IPC standard. Clear?
Yeah, okay.
And based on the every fixtures. Okay. Okay. Now I want to do the water supply fixture unit calculation. How I will do? I will go to the one of the toilet. Say for example, I have a very big projects, right? So what is my scope? I have a tank somewhere nearby. I have a tank. From the tank, my pipe will be running all the way to the toilets, right? So you can see, for example, there is a pipes coming from the riser. Okay, from the riser, there is a multiple water meter going to the tenant area. Okay, so this particular water meter, say for example, this particular water meter to the one tenant, this water meter to the one tenant, this water meter to the one tenant, right? So this tenant, say for example, toilet is one of the tenant or landlord area, right? So this particular pipe is going to the toilet, right? So I want to size this particular pipe. So in this particular pipe, when I do the sizing, right? So I should calculate water supply fixture unit calculation. Then only I can able to calculate the pipe size. Okay. So how I will do the water supply unit fixture unit calculation based on the number of fixtures. So what I will do, I will calculate 1, 2, 3, 3 or 4, right? So say for example, I have a 3 WC. So when I go to the Excel sheet, okay, I will remove all the quantity here, right? Okay. And I'm going to put, say for example, I have a 3 WC, flush tank WC, public. Okay. So I will use this 3. So what is my total fixture unit? 15 numbers, right?
Okay, 15. What about that hot water fixture is 5?
No, no. See here, you can see that only cold water, right? There is no hot water
Oh, okay.
because it is a WC, right?
Yes, yes, understood. Okay,
So you can see that this is my total fixture unit calculation. So this is 15. So what I will do when I prepare schematic, say for example, I am not experienced guy. Okay, I'm a starting, I'm a learner. Okay, what I will do, I will put my this particular area. I will just put instead in the bracket. I will put here 15 WC. Okay.
Okay, okay. Fixer unit. Okay.
Yeah, fixture unit. I will put 15. I forget about the pipe size here. Just to concentrate on only WSFU. Okay. So I will put
Yes,
here
okay, okay.
15 WSFU. Okay. So okay. Then I'm going.
Okay.
I'm taking this line. What is this line? I have 1, 2, 3, 4, 5 urinal. Okay. So what I will do? I will remove this, and I will put 5 urinal public flush tank. Okay. 5 urinal. So here how much? 15. Right.
Okay.
So this is 15. So what I will do? I will put again here 15.
Okay.
Okay. Say for example, I see here you can see 20 mm, 25 mm, 32 mm. So if I see 2 urinal, what will be the WSFU I can put here, right? If I add another 4 fixtures or 5 fixtures or 4 fixture, I can put what is the WSFU. So each and every urinal I can put the pipe size, right? I can put my WSFU value here. Here what is that? 3. Here 6. Here it is 9. Here it is 12. Here it is 15, right?
Okay.
So
But
in that
no,
way,
we,
I
we
can,
should,
yeah.
no, we should calculate total fixer unit or each
See,
fixtures we
see.
need
Actually
to.
speaking, you can able to calculate total. If you calculate total, you have to provide 32 mm pipe size for all the area, right?
Yeah. Okay.
If you want to save cost, so you can do some accurate calculation. Okay, you can do how much, what is the fixture unit up to here. So based on that, I can do the pipe sizing. Up to here, what is the fixture unit? I can do the pipe sizing based on that. And here, what is the fixture unit? I can do the pipe sizing based on that, right?
Yeah. Okay.
Okay, so I can able to size the pipe here. I can able to size the pipe here. I can able to size the pipe for ablution area, right? Based on that, I'm talking about not pipe size. I'm talking about only the flow rate, WSFU, water supply fixture unit calculation. I can put all the WSFU for each and every area location, right?
Yeah. Okay.
Is that clear, Rajesh? So say for example WC, here 5 WSFU, here 10 WSFU, here 15 WSFU, right?
Okay.
And here 3, 6, 9, 12. I can use that WSFU like that. Here also I can use the WSFU. Okay, when I combine all these 3, I can put the total WSFU here, right?
Yeah. Okay.
So I can use this Excel sheet to calculate my WSFU. Okay, so based on the WSFU, I can put all the WSFU here. Here, how much WSFU to this area. Then I can calculate, for example, this particular area, restaurant. What is their requirement? What is their fixtures inside? So based on that, I can able to calculate my WSFU. And based on this restaurant, what is the fixtures inside? Based on that, I can calculate my WSFU. So I can calculate all the WSFU here, right? Is that clear?
Yeah.
So in this way only you will do the WSFU, water supply fixture unit calculation. Say for example, if I go to my project, assume that I am going to open one of the schematic, right? So if you open the schematic, I can able to calculate WSFU for this particular apartment. What is the total WSFU? What is the total WSFU, right? So if I know all the WSFU, then I can size my header here, right? See here, 32, 32, 32. But when I calculate all the WSFU, this particular will be 63 dia. So this 63 dia, how it came, depends upon the total WSFU.
Okay, that WSFU and the pipe size, that table you attached in the documents.
Yes, I have attached in the document. Okay, so first we will calculate WSFU calculation, then we will go to the pipe sizing, right? Is that clear? Okay. Now I have calculated all the WSFU here. Okay. Now what I am going to do, I am going to calculate the flow rate now. Right? So how to calculate the flow rate? Say for example, if I open the standard, okay, you may remember this standard, right? IPC standard. Okay. If I go down, okay, in this particular sheet, you can see that there is a water supply fixture unit, right? Correct. So here I can able to see what is a water supply fixture unit here. Say for example, if it is 1, I can calculate the GPM flow rate. Say for example, if I go to here, what is the WSFU here? 15 WSFU, right?
Yeah.
Right?
Where were 15?
Here, this particular area, because it is each WC having 15 WSFU, right?
Yeah, okay.
You're clear? See,
about.
if you go to this particular Excel sheet for the water closet public flush tank, I have a 5 WSFU for one number. So for one number WSFU 5 number. So that means 5, 5, 5. So total will be 15, right?
Okay. No.
So what is the flow rate?
Can you open the Excel sheet, please?
You can see the Excel sheet here. So
okay,
what is the quantity? This is the quantity, right? For one WSFU, yeah, okay. This is the quantity. One WSFU, what is the fixture unit? 5.
5.
So here if you see, this is the 5 and this is 10. This is 15, right?
15. Yeah.
So what is the flow rate here? For 5 WSFU, what is the flow rate? Go to that sheet and for 5, this is my flow rate, 9.4 GPM.
Okay.
And for 10, 14.6. So on this rate, this particular location, I have a 10 WSFU and the flow rate will be 14.6.
Okay.
And if I go to this one, 15, I have a flow rate of 17.5, right?
Okay.
So in this particular location, 17.5 GPM. So similarly, you can calculate for urinal. You can calculate, right? Because you know you are going to put WSFU everywhere, right? So based on the WSFU,
one thing, but we don't want to show in the drawing during the design time. We don't want to show in the drawing, right?
In the drawing, it's not required. In the drawing, it's not required. But just for learning, I am explaining.
Yeah. Okay.
Okay. So you can say that this is the WSFU, so and so WSFU, so and so WSFU, so and so WSFU. So you know, based on the WSFU, go to this particular chart and you can able to find out the flow rate here. Is that clear?
Yeah. Okay.
Clear, Nizar?
Yeah.
Rajesh?
Yeah.
Clear, right? So you can able to put the flow rate everywhere, right? You can put what is the flow rate in this location. What is the flow rate from here? What is the flow rate from here? So when you add all the flow rate, this is my total flow rate, right?
Okay.
Okay. So this is the way to calculate all the flow rate. Yes.
How we can consider for the water heater?
No, I will tell you. Water heater is a different calculation. Okay, that I will explain you. That is a part of hot water system. Now we are talking about domestic water system. Okay, what is the
No,
water?
we give the cold water connection to the
Yes, that I will tell you. That I will tell you how much flow required for the hot water. Right?
See, you said that for the fresh tank. I mean this WC. This water supply fixture unit is 5. How you derive these 5?
Okay. If you go to the standard,
Yeah.
that is what I told you last time. We have to go through the standards, right?
Yeah.
So this standard, this is the load value assigned to fixtures. So if you go to down, water closet, right? Public, flush tank. Can you see 5?
Yeah.
So
This
whatever
public
this, public is 5.
yeah. Private is 2. Okay.
Private is 2. So whatever in this table, we made it as an Excel sheet for our calculation purpose. So this particular sheet taken from IPC standard.
Yeah. Okay.
Clear, right?
Yeah.
Okay. So now everyone understand that how to calculate water supply fixture unit calculation, how to calculate water flow rate, right?
Yes.
Okay.
Up to here, anyone have doubt?
No, it's okay.
No. So
Clear, right? Okay. Now again, if you go to the plumbing code, okay, now we are going to calculate the pipe size, right? So what is how to calculate the pipe size? I think I have sometimes back last week, I have explained you the chapter 6.
yes, I remember. Yes, I remember. Yes.
Okay. Now what is the velocity? Anyone remember?
4.
Yeah, tell me. Correct.
4 feet per minute.
Yeah, 4. Yeah. See, if you go to this particular table,
Seconds. Yeah. You said 4 and 8. Yes.
if you go to this table, can you see this manifold sizing? This is the pipe size, and what is the velocity? Range from 4 FPS to 8 FPS. This is the range. Okay.
Yeah.
If you go lesser, you have a less pressure where water may not reach to the fixture. If you go more, there is a chance of leakage because the pipe may damage. Okay. So this is the recommended velocity as per IPC standard. So 4 FPS to 8 FPS. Okay. And you can see the flow rate here. 2 GPM to 5 GPM, I can use half an inch pipe. Okay. 6 GPM to 11 GPM, I can use 3 by 4. For 10 GPM to 20 GPM, I can use 1 inch pipe, right? Okay. And okay, so this is the standard. Okay. Now, what is the pipe material we are going to use? We can use different pipes, right? In the water supply system. Okay. Now, if I go further down, okay, you have a chart. What is the chart for the pipe sizing? Okay. So if I go further down, you can see the pipe size chart for different materials. This is the copper pipe, right? Okay. So you can see here, this is the pressure drop, PSI. Pressure drop per 100 feet of tube, pounds per inch, PSI. Okay. So this is the PSI value, pressure drop. Okay. And what is here? It is the flow rate. And what is here? Velocity, right?
Yeah, okay.
And what is here? Pipe size. You can see the pipe size, half an inch, 5 by 8, 3 by 4, 1 inch, right?
Okay.
So this is for copper pipe. And if you go to this pipe for another copper pipe, different material, different type. Okay. If I go here, this is also another copper pipe. If I go further, this is the smooth pipe, fairly smooth pipe. This is the fairly rough pipe, right?
Yeah.
This is the rough pipe. So what is rough pipe? Assume that I'm using cast iron or concrete pipe. Say for example, if you go to outside, you have a very concrete where you can transfer the water at high level, at huge volume, right? Where you have a concrete cement pipe, right?
Yeah.
So that inside surface will be very rough. Okay. And if I go to fairly rough pipe, fairly rough, nothing but you can say you are using GA pipe or some ductile iron pipe where you have a inside will be fairly rough. Okay. It is not smooth pipe, right?
Yeah.
And what is smooth pipe? Say for example, you are using plastic pipe like PPR or PVC pipes. So if you touch the inside plastic pipe, you can see the surface will be very smooth, right? So normally in water supply system, we use PPR pipes like smooth pipes. Okay. So in this particular graph will be used for the pipe sizing. So how to use the this particular chart, say for example, I am calculating the flow rate. You agree? You calculate the flow rate, right? Assume that this particular area I have a 15 WSFU. For 15 WSFU, if I go to the standard, I will get the flow rate, right? So for that flow rate, I can chart here, I can put plot here. Say for example, my flow rate will be 10 GPM or 20 GPM. Okay. So if I draw
20.
straight line, if I start straight line, and where is my velocity? Velocity is here, 10 feet, 8 feet, 6 feet, 5 feet, 4 feet. So my pipe size should be between the 4 to 8 feet, right? FPS. So if I go 20, if I draw a line here, okay, I can say that this is the 4 feet and this is the 8 feet. So my pipe size can be within this range, right? So if you want, I can draw here. So this is a 20 GPM, and if I draw the pipe, okay, and where is the velocity? This is the velocity, 4, 5, 6, 8. So my pipe size will be between this line, right?
Okay.
But whenever I design my pipe as a designer, I will consider plus or minus. So what I will do, I will design my pipe size for 6 feet, so that the pipe maybe sometime the flow may go here or there, right? So I will be considering in between, intermediate. Like I will not go for 4, I will not go for 8, I will go for 6 for safety design, right? For safer design. So if I go here and this intersects here, right? Okay. And what is the pipe size? Say for example, this is 3 by 4, right? This is 3 by 4. And this pipe, assume that the pipe size is not given here, but I will assume that it will be like I can say 1 inch. Assume like that, 1 inch, right?
Yeah.
Okay. And here I can say 1 3 by 4 or 1 by 4. Okay. And here it will be 1.5 inch, right?
Yeah.
Or I will say in mm. Okay. This is like 15 mm. This is 20 mm. Yeah, this is 25 mm, 32 mm, and say 40 mm, 50 mm, right?
Yeah.
Okay. Now where the pipe intersects here, somewhere intersects here. Okay. So what will be the next large pipe? Next pipe size I can go, because this particular line will be something like this, right? So what is my next pipe size? It will be 1 by 2, which is called 40 mm, right? So for this 20 GPM, for this velocity, I think I have to go with 6, right? I have to go with 6 here, 6 velocity. So if I go with 6, I can go this particular pipe size, right? So what is this one? It is nothing but 32 mm. Okay, so because this line intersects here, right? Intersects here, this particular portion. So it is intersects here. So here, what is the next pipe size? This pipe size, right? So what is this particular pipe size? I will say that it is 32 mm in mm. Otherwise, 1 by 4, or I can say 32 mm, because this is the line, intersect line, right?
Okay.
And what is the next size? 32 mm, right? So in this way, I have to, yeah.
But first one line clash with the velocity 4. That one we don't want to consider.
No, see, that is what I said. What is the code says? The code says 4 to 8. Okay, but just for safer side, plus or minus here and there, I will be considering 6, so that when the flow goes here or there, I have a safety factor, right? So I will be going with the 6 feet per second. You can go with the 4, you can go with 8. That doesn't change any concept. Okay, assume that I am going with the 6 for my safety purpose. Okay, because the flow rate can be here and there. So I will be selecting this particular pipe size, right?
Okay, after the intersect point, how you select the pipe size? Because the chart you need to see outside.
Yeah. See, for example, this is the my line, right? So what is the line here? This is my 25 mm pipe, right?
Okay.
But this is greater than 25 mm. This is greater than 25 mm, correct?
Oh, okay.
So I'll be going with the standard pipe size, which is next pipe size 32 mm.
Okay.
So in this way,
Okay,
I will be designing my pipe size for each and every location. This is the concept. Okay. Say for example, if I go to here, okay, what is my total WSFU and what is my total flow rate? Go to this chart. Based on the flow rate, based on the velocity, I can calculate my pipe size. Is that clear,
So
Nizar or
No,
Guru, Rajesh?
only the chart is the way to choose the pipe size, or any other Excel sheet or something available?
See, actually speaking, you can able to calculate. Yeah, this is only the chart, basically. To calculate the pipe size, only the chart.
We don't have any the option to select the pipe size against the GPM like this.
See, you can if you go to the standard, there is a table, right? You might have seen the table. What
Okay.
it given each and every pipe size. What is the flow rate to what is the flow rate? What is the flow rate to what is the flow rate, right? That is a
Okay,
table.
so we can, yeah, okay.
You can also make a table. Say for example, I will tell you that for 20 GPM, my pipe size will be this much. Okay. And for 30 GPM, my pipe size will be this much. For 50 GPM, my
No,
pipe size will be this GPM, right?
Yeah, why I'm asking this doubt, when we are going to be busy in the design, so every time we can't use this chart, so we need some
No,
shortcuts like
no. You
okay.
must use this chart. You must use this
Okay.
chart
Okay.
because we are a designer, right? We are doing calculation based on codes and standards. So whenever you do the chart, this particular chart, you should be in your hand. So based on this particular GPM, you have to calculate here. You have to put it in your drawings. Whenever you prepare schematic based on the flow rate, you have to calculate the pipe size based on the chart.
Okay, all right. Okay.
Clear, right? Is it very clear, right? Based on the flow rate, based on the velocity, you can able to calculate the pipe size. Do you have any questions, Nisar or Rajesh?
No.
Yeah, once let me go through all these things, then I will come to you.
Okay, so you can go
Yeah.
through and you
Yeah.
can able to understand up to pipe sizing. Okay.
Yeah, yes.